How can a semi-truck small enough to fit inside a residential garage still produce real mechanical torque, tow weight, and even compete in pulling events without being classified as a toy? A scaled-down semi-truck rolling out of a garage instantly draws a crowd and a wave of raised eyebrows. At first glance, the proportions seem almost playful. A cab that stands just above 5 feet tall, a wheelbase cut nearly in half, and a total length somewhere between 50 and 75% of the highway giants these rigs imitate. But the surprise is not just about dimensions. It is about disbelief. Spectators, used to associating size with strength, question whether a truck this compact can truly deliver on the mechanical promises its full-scale siblings make every day. Some dismiss it as a novelty or a toy, convinced that anything fitting inside a standard garage cannot possibly generate real torque or handle a loaded trailer. Others challenge the builder's credibility, wondering if the chrome stacks and air horns are just for show. Yet these mini semi-trucks do not exist in a vacuum. They show up at truck shows, parade grounds, and even competitive pulling events, where the line between spectacle and substance gets tested in front of an audience that knows what real power looks like. The skepticism is more than casual. It is a cultural reflex, rooted in decades of equating big rigs with heavy-duty work. For many, the idea of a semi that is half the size but claims a working drivetrain and towing capability sounds like a contradiction. But the builders behind these machines do not just invite scrutiny, they expect it. Their challenge is not just to shrink the silhouette, but to preserve the essence of what makes a truck legitimate. That tension between what the eye sees and what the machine can actually do drives the debate over authenticity. If you are fascinated by the hidden engineering behind machines that defy expectations, consider subscribing. This series goes deep into the overlooked corners of mechanical culture, where scale is just the beginning of the story. Builders face a split decision from the start. They can use a factory pickup chassis or build a frame from scratch. The pickup-based route means cutting down a Ford, Chevy, or Dodge light truck frame, reinforcing it to handle new demands and keeping the original V8 engine and automatic transmission. These engines, delivering 400 to 460 pound-feet of torque, are paired with aggressive gearing, with first gears near 3-to-1 and final drives as low as 4.10 to 1. This setup multiplies torque at the wheels, letting these rigs tow several thousand pounds at low speeds. The familiar driveline comes with real weight and complexity, so builders must strengthen frames and axles to keep everything in check. Others start with nothing but raw steel. Tubular frames welded by hand become the backbone for small industrial engines or high-revving motorcycle motors, sometimes with just 10 to 20 horsepower. On paper, these numbers seem modest, but the secret lies in torque multiplication. Ultra-low final drive ratios, often over 5-to-1, and manual or planetary gearboxes can push more than 900 pound-feet of torque to the wheels. With less than half the mass of a pickup-based build, these trucks do not need brute force to get moving. Clever gearing turns a small engine into a capable hauler, ready for scaled trailers or pulling contests. The choice reflects each builder's philosophy. Some chase the reliability and muscle of a V8, others chase the efficiency of lightweight design. Both paths demand careful engineering, with reinforced frames, tuned suspensions, and brakes sized for real loads. In the end, legitimacy comes from generating and controlling true mechanical force. Every credible mini semi-truck starts with the same question: can a scaled-down frame truly handle real mechanical stress? Builders answer with steel, sweat, and careful calculation. Whether the backbone is a shortened pickup chassis or a custom welded tubular skeleton, structural integrity is non-negotiable. Boxed frame rails, gusset plates at critical joints, and cross members built from ASTM A572 or 4130 chromoly steel create a foundation that resists twisting under torque. These reinforcements are not just for show, they are the difference between a truck that flexes and one that hauls. Suspension choices reflect the same seriousness. Leaf springs, borrowed from full-size pickups or upgraded to coil-over systems, are chosen for their proven ability to handle thousands of pounds per axle. The spring rate is not guessed. It is calculated to support both the static weight and the dynamic forces of towing. Adjustable coilovers sometimes take the place of leaf packs, offering fine-tuned ride height and damping for different loads. Each bracket, weld, and mounting point is scrutinized because a misstep here can mean axle hop or catastrophic failure under load. Braking systems are built to match the ambition. Heavy-duty disc brakes, sized for the vehicle's gross weight rating, are paired with proportioning valves to balance front and rear stopping power. Brake torque targets are set at 60% of vehicle weight, so a 7,000-pound build needs over 4,000 pound-feet of stopping force. This often means dual caliper setups on the rear axle and high-temperature pads, mirroring the logic of commercial trucks. None of this comes cheap or easy. Material costs for a high-end build routinely climb past $20,000, with labor adding hundreds of hours. $300 to $500 for a professional shop, and often more for a hand-built custom. Every hour spent welding, grinding, and aligning is an investment in safety and credibility. In this world, shortcuts are rare, and the price of admission is paid in both dollars and dedication. A mini semi-truck idling on a museum floor does more than echo the lines of a full-size rig. It stands as a statement. At the American Truck Historical Society's rotating exhibit, a running Cabber Mini, built from a shortened pickup chassis and finished with working air horns and authentic lighting, sits beside the highway giants it emulates. The curator points out the functional details: a reinforced frame, DOT-approved brakes, and a transmission that can shift under load, not just for show but for real mechanical work. This is not a static replica. On select weekends, staff roll it out for operational demonstrations, letting visitors hear the V8 engine turn over and watch the drive wheels engage. The crowd's reaction shifts from amusement to respect as the truck tows a scaled trailer across the lot, its exhaust note and forward motion proving its point. Events outside the museum walls add another layer of validation. At regional truck gatherings, these mini rigs line up alongside full-size tractors, their owners trading stories about fabrication hours and maintenance routines. Enthusiasts gather not just to admire the craftsmanship, but to watch the trucks perform, hooking up to small sleds, maneuvering through obstacle courses, or simply idling in parade formation. Community judges inspect each build for functional systems, real suspensions, working air brakes, and the ability to tow according to class rules. Ribbons and trophies go to trucks that combine authentic engineering with reliable operation, reinforcing the idea that legitimacy comes from function, not just form. Behind every public showing is a culture of meticulous care. Owners spend weekends tuning carburetors, bleeding brakes, and checking welds for fatigue. The maintenance rituals mirror those of full-scale truckers, underscoring the seriousness with which these machines are kept roadworthy, at the very least show-ready. For many, the ultimate endorsement is not a plaque on the wall. It is the nod of approval from a veteran trucker or a museum curator who recognizes real engineering, no matter the scale. A hush settles over the arena as the event organizer steps to the microphone, clipboard in hand. Before any engine roars to life, the rules are laid out with precision. Each mini semi-truck is weighed and slotted into a class based on its gross vehicle weight rating and engine displacement. The pulling sled itself is a feat of scaled engineering, a steel pan loaded with progressive ballast designed so that as the truck advances, a weighted box slides forward, increasing friction against the dirt track. This system ensures that every inch traveled demands more from the drivetrain, simulating the relentless resistance full-size rigs face in sanctioned pulls. Safety checks are non-negotiable. Organizers inspect hitch points, confirm functional brakes, and verify that ballast is distributed to keep the drive wheels planted. Some builders stack steel plates over the rear axle, while others bolt custom weights to the frame, fine-tuning traction for the crucial first moments of the pull. The class limits are enforced down to the pound. No truck may exceed its gross vehicle weight rating or use an engine larger than the posted maximum. These boundaries level the field, making the outcome a matter of engineering, not just raw power. Engines idle, transmissions slip into low gear, and the first contender hooks to the sled. The signal drops, tires bite into the clay, exhaust stacks bark, and the sled's resistance mounts with every foot. The tension is palpable as the truck's speed drops, wheels churning against the growing load. At the 275-foot mark, the sled's weight box reaches its forward limit. Against all expectations, the mini rig keeps moving. Inch by inch, it drags the full load past the 300-foot line, a full pull. The crowd erupts, but the numbers speak louder than applause. This scaled-down machine has delivered measurable proof of real mechanical output under rules as strict as any full-size event. Right now, these scaled-down rigs prove that mechanical legitimacy isn't measured in feet or tons, but in engineered systems and intent. As engineering subcultures keep redefining what is possible, the line between model and machine blurs. Subscribe to join us as we uncover more misunderstood machines and hidden systems.